Yeah, good brew, Jenkins, you're getting better. Hello, welcome to Tweed's Garage. In this video, we're doing a bit of reorganisation. Yeah, that's why I'm over here, because it's like a bomb's gone off in the workshop. And what I'm doing on this video is moving a lathe. Doesn't sound that much, does it? But yeah, the Colchester student that I've got weighs over 840 kilograms, which is about 1,750 pounds in old money. And I need to shift it, need to gain a bit of space. So I'm going to show you how I went about that. And to explain all that, I'll pass you over to the idiot in the workshop, over there. So, got a little job to do, bit of reorganising again in the workshop. Yeah, it's always happening, always new stuff comes in, got to find homes for it. Stuff's moved about, you know, robbing Peter to pay Paul, all that kind of thing. The workshop is 16 foot by, yeah, bit snug as you can see, 16 foot by 12, which sounds reasonable, but when you've got a full-size Bridgeport milling machine and a Colchester 1800 lathe in here, as well as all the tooling to go with it, and motorbikes all around, bits and bobs, air rifle, shot brackets, you know, I'm like a womble. Space is an issue, and if we can sort of rob Peter to pay Paul, a few more inches of space would be really nice. Now, when I first got the lathe, or as it is now in its current setup, the splashback at the back, which is the genuine one, dropped back a bit to allow space for the digital readout. The digital readout fitting is on the back here, and I've been having a look at this. So this is one of the jobs I want to do. I want to try and gain, I've got about 1.5 inches space behind the splash shield to the wall. I didn't worry about it initially because there is a sort of space big enough for me to crawl behind if I needed to get to the coolant tank or the electrical connections at the other end. But it's been in 3 years now, and all I've done is shove junk behind there. So I don't think it'll be an issue. Well, apart from trying to find space for the junk if I manage to move it back a bit. But anyway, so the plan is to try and gain, if I can, 6 inches.
Mr. Powers.
Quickly, come on now, let's go.
So put this coolant splash guard back in its original position, so it comes sort of back and down a bit. You can see by the sides where it sort of should go. That'll allow me to hopefully move the lathe back. Yeah, 6 inches would be really good. It'd sort of bring the lathe back to here. So there's that to do, but what I've got to do is yeah, rejig this digital readout scale at the back here. It's all sort of really over engineered. There's bits sticking out. It doesn't need to be that long. I'm not running, originally it used to run flood coolant, so it needed to be well protected, but I don't run flood coolant, so that's not so much of an issue. And also because I've got a welder, they're only bent up shields that go on it, I can actually sort of weld some ends in as well, just to make it a little bit more swarf tight. So yes, I've been having a little look around it, and I was sort of planning on going upwards, but I think actually it'd be better to drop the scale downwards and lose some of the metal on the top, lose some on the back, move the scale this way, and I might even gain a little bit more movement on the cross slide as well, which would be a good thing. So there's that to do. I'll bring you in and show you what I'm planning to do, and then as I'm working through it, I'll sort of update you how we're getting along. So that's one job. And then another job is, as with these lathes, I mean, these were sort of designed, not sure, probably end of the 60s, definitely 70s. But even then, average height was a little bit shorter. So I do find, you know, you are sort of bending down a little bit to operate stuff, and it does sort of get you in the back after a while. So I'm going to turn up, I've got some big chunk of steel round bar somewhere, going to cut some slugs off of that and make 6 feet, you know, just to bring it up, hopefully a couple of, as I'm, you know, bring it up a couple of inches. And as I've got to move the lathe anyway, shove it back, possibly lever it up, push it on skates, they can then be put underneath and then it all leveled again. Bit different from the motorbikes, but that's what we're going to do, and I'll bring you along with me. All right, so first thing to do, try and sort out first, I think, is these scales. Get these scales sorted out and tucked in, and then see if we can get the splash guard back in its original position. Yeah, so here's the scale setup here. So we've got, yeah, quite a lot of metal hanging out all over the place. I mean, we could gain, you know, an inch sort of lopping it off back here, getting rid of some of this. But I think what I can do is move this scale this way. I think if we can get 2 inches this way, that will give me all the clearance I need. And I was sort of planning on moving this up because we have a bit of a clash between the top of this when it's got the guard on. Where's the guard? I have trimmed this a bit already in the time that I've had it. I can't remember where I trimmed it, but I've trimmed it. Yeah, so it's cut out here, so it goes around tailstock there, but the height of it's going to bring it up a little bit and that way a little bit, but I don't gain anything, because if you look here, what happens is this hits the tailstock here, you know, where its sort of throat drops down there. So I think the plan is we can come further out. You see the scale, if it was lower, you know, if we went sort of dropped it a centimetre lower, which we've got clearance to do here, we can drop it down quite a way. It will drop down quite nicely under the front of the tailstock there. I mean, you'll always have this distance. You've lost this distance, you know, because of the base of the tailstock's always going to hit whatever's here. So, but if I drop it down, I do gain that much movement rather than sort of back here. Yeah, you can see where the guard's been catching it over the years, there and there. So yeah, that's the plan. Drop this down, move it along, because it doesn't matter if it's going to miss. It can go further this way, and then move the sensor that way. So move it all, if I can make it about 2 inches that way, so we can lop a bit of this off. We can lop the back of that off. So I've got the plate off, come off all right. I think I forgot about these little mounting plates that the scales come with. You know, it's to allow adjustment up and down and side to side. I think what I might do is, because this is pretty generous for mounting scales, you know, they sort of don't have to be this solid. What I might do is mill a slot to drop this in, and it will just move the scale further towards this surface, you know, and we're just sort of pinching millimeters just to gain a bit of clearance, you know, on the back of the tail slide here. But yeah, unfortunately, you see flood coolant in its life. This plate was open at the end because there's a V in the bottom of the cross slide, and this is the gunge that has got forced down there over the years. So we'll clean that out. There you go, it goes all the way along, look. So we can either seal it up with a bit of silicone one end just to stop it gooping up, or maybe just remember to pass the airline down there occasionally just to clean it out, because it was actually starting to form a bit of rust. But luckily this is good quality iron these are made from, so it's always just really surface rust. Doesn't really affect it too much once you scrape it away, clean it off with something. So anyway, getting sidetracked again as usual. That's it, looks a bit better. I'll give it a good clean before we put it back on properly. There we go. And here we have the scale back on the lathe, all fixed now. This is all cleaned up, trimmed to length, all set up. And then the guard I've trimmed a lot off each end and off the side because I've sort of tucked it in this way a bit. Yes, it looks really good. I will put some end covers on it just to sort of, you know, stop the swarf getting in here. But for now I need the lathe working to be able to turn my feet up to be able to move the lathe, one of those sort of catch-22 situations. So yeah, with that done, the lathe is now up and operational again, and the back guard is on in its original position. But sort of looking at it, I think that was an optional position because you've got a sort of plate here and there was a plate there and they painted lathe colours, so I think that's as they came. I mean, they might have put the extra holes in. But anyway, and as you see, that gives me now, where this is, 8 inches from here to the wall. So I've got about 7 inches, I reckon. I'll be able to move this lathe back, which is, yeah, happy days. So about, you know, about to here. Yeah, right, carry on. So I found me a bit of steel stock. I'm going to turn my pads up for the lathe feet. It's 2.5 inch diameter. I've got plenty on there to be able to turn up 6 2-inch blocks to go under the adjusting bolts. It's quite a large piece. Could stick it in the bandsaw, but what I'll probably do, as I've done before with this, is pop it in the lathe and run it on the fixed steady and then part off chunks on this end, you know, and work my way along sort of thing, because I can sort of turn them down before I part them off then. So yeah, so that's ready to go. Okay, so got the back panel sorted out, got that raised up. As I said, it's gained me about 7 inches of movement backwards, and as you see, I've turned up 6 riser feet just to bring the lathe up about 1.5 inches. Doesn't sound a lot, but when you're working with it all day, you know, it just brings those handles up a little bit higher so you're not sort of leaning over the machine all the time. And then they'll go under the adjusting bolts. There's one here, one at the back there, 2 at the front and another 2 at the back on the head end of the lathe. And what I'm going to do in a minute is take the tailstock off, take the tool post off, take the chuck off, you know, just a few pounds lighter, just makes things a little bit easier. And then we've got all the tools that you need. We've got a crowbar, and this lathe has little notches for it to go in. It's really for toe jacks, but I haven't got a toe jack, but a crowbar resting on a bit of wood just to bring its lever point up a little bit higher, and you can see there, just sort of standing on it is enough to lift the back end of the lathe off its adjusters. The other end will be a little bit heavier, but same sort of thing. And then we've got a sorted pile of wood offcuts just to sort of bring the height up, and some more pieces here. And then the most useful thing when lifting machinery, wedges. They're the best thing ever. You can just sort of lever it up a little bit and just keep pushing the wedges under, having a break, repositioning stuff, and then you know, put another block under your crowbar, pry bar, and then carry on going again. So yeah, really useful. Just cut yourself a couple, and they always come in handy. And then got some machinery skates here. I've had them for a while. I had a dead car to try and move. Yeah, it didn't work very well. And the same problem, cutting edge engineering had the same problem. These sort of Chinese made skates, I mean, all the bits are there, but I think most of the bearings, this one especially and this one, they're not pinched where you see they've got the washers are loose here, so there's no side loading on the inner races of the bearings, so they just spin around the bolt rather than the bearing actually spinning. But anyway, we may use those, or we may just sort of lever it, you know, just hop it over one side and then hop the other side over. So I'm going to sort of get some metal off of there and then get on with moving it. This is the trouble, we run out of space everywhere. Right. Just protect the ways. Move a bit of weight down that end. Okay, right, I think we're about ready to go, and I think my lifting slot, that end, I'll still be able to get to it when I move it back 7 inches, so that's good. Okay, let's get lifting. Start by putting our wedges underneath each side there. There you go, you can make fast progress. Look, we're off the ground already. Closer. Give us another little bit of height. See if we can scoop one of those under there. Yeah, I think so. Take our wedges out. Start putting blocks underneath, like that. There we go. I think we'll start levelling the other end up, getting that up on blocks. Otherwise we'll have too much weight to lift. So, forgot to press record. That's why I'm out of breath, but we got this end up on blocks, on its first set of blocks, and the same way, packing under the pry bar, leaning on the pry bar, knocking the wedges under bit by bit, and then repositioning and putting another packer underneath and just sort of going up like that, a little at a time. So we just check the other end, make sure it's okay, and carry on from there. Now we're trying to slide it towards the back. So found the best way is put the pry bar under this corner and then lift and slide it across the wedges, and then reposition these once you've moved it a couple of inches, like that. And we're sliding under the shelf there. This is why I couldn't use the skates, because I wouldn't have got it under the shelf, which would have mean taking all the shelves down, all that off, finding home for that in here somewhere. And the heavy end, I've got a bit of steel bar stock under that corner, wedges over here, and then the same thing, put the pry bar in there and sort of lift and push, and it rolls back on this roller here, and then just come back and check this doesn't go too far this way. We want it, you know, so we don't want it toppling over. But yeah, getting there, closing the gap. is, you can see there, that's where it was, and that's where it now is, supported on its feet. So it's brought it up, as you saw in the earlier video. Yeah, it's sort of just tucked nicely under the shelf there at the back, and gives me a bit more space, and I'm also closer to the shelves as well, so it's easier to reach across and grab the tool holders. So good job done. So as well as moving the lathe into its new home, whilst I was going through the drawers reorganising stuff, I rediscovered this Silvac digital scale for the quill on the Bridgeport. It came with the mill, but it didn't come with any of the, it came with the clamps top and bottom, and that was it. It didn't have, you know, for these Bridgeports you can get like a C bracket that goes behind, but it normally mounts on the screws just there, on these two screws on the ruler scale on the head here. One of them's really short. It sort of interferes. Yes, this one. This one's really short because you've got this rod that goes up through. This is the trigger to knock off the down feed, goes up through there and knocks this block here off, which knocks that out. So I had a little look around, see what I got, and I've got a big plate of chunky aluminium, which I clamped down on 1, 2, 3 blocks on the mill, and then just worked out my size of the bracket. Basically just put a slot drill in it and then just ran round the marking out I'd made for the bracket and just cut it out of the plate, sort of a milled finish. Just deburred the edges and then positioned it up here. Now on the Bridgeport here, there's a little flat edge here and a flat edge here and a little ridge or shoulder there. And the reason this is for quick alignment of the heads. You can put a steel rule, you know, on there like that, resting it up against these shoulders to set the head up vertically. But that's sort of just by eye really. But yeah, that's meant to be machined in the centre of the quill. If ever you need a datum on a Bridgeport. I never use that. I use the tramming gauge set or a clock to set the tram up on the mill. So sort of surplus to requirements. And there's a decent piece of material behind here before it goes into anything. So just drilled the bracket and then clamped it in position and drilled one hole, tapped it, put my Allen screw in there to fix one end, and then went and drilled and tapped the other hole, and that went really well. Just drilled it with an battery hand drill and using the hole. I drilled the holes in the plate on the drill press so they were parallel and straight, and then just used them as a drill guide to drill my hole into the head of the mill, and then just followed in with a tap, I think 5mm tap. So bolted that on and then drilled it and tapped it for the little clamp arrangement that holds each end of the digital scale. It's just clamped in these little pinch clamps top and bottom, and that works really well. And then measured and sketched out an L plate to go on the back of the digital readout, and it's tiny little M3 screw threads in the back of it, and they're only about 2mm deep, 2.5mm deep. You can't go in too deep, otherwise you'd pinch it on the back of the scale here. So I just had to cut down some stainless steel screws, screwed that on the back there, and then on here on the Bridgeport there's a hole in here at the top of the quill stop. I think it is for when you drop this thread out. I think it's so you can get through, and there's a screw that holds this stop onto the quill, so you can take that off. So it's just an access hole there. But just measured that and then turned down this shouldered brass button so it was a tight tap fit into there, and that allowed me to sort of set it to the correct height for this bracket so it wasn't straining. So it's a nice sort of fit there. Drilled and secured it like so, and then left the bottom clamp loose, pinched it up at the top, moved it up and down So I knew it sort of centralised itself, and it was all going to work fine without rubbing. With it all mounted on, you just turn it on by pressing the button, and you can zero it, and then just move it up and down. You can see it reads perfectly. You can convert it from metric to imperial, just at the push of a button. And with this digital readout on, I can only go down to there. I lose about an inch of travel just because of the nature of the install. The scale would have to be hanging down here to get your full travel, or up there, and it would get in the way. So you sort of sacrifice an inch of travel on the digital readout. But it's easy to disconnect and regain your inch of travel. You just take the Allen screw out the top there, move your stop back down to where you want it, and just do it the old-fashioned way. But that'll give you your full 5 inches of drop. But you very rarely use that. You know, you're only drilling holes sort of an inch, a couple of inches deep normally. So this is perfect. Yeah, and then you just hold the button and off it goes. Swiss made seal vac. I don't know how old it is. I don't know whether they're still going. But in the instructions it says the batteries last 2 years. Very similar to the Mitutoyo micrometers and calipers. They last sort of just over 2 years, almost to the same day if you change them in different instruments. It's quite incredible. Yeah, so yeah, very pleased with it. And this is just a push fit in here. It's quite a tight fit, but it's perfectly adequate for just moving this lightly up and down the scale, and it sort of stays where you put it. If it ever went a bit slack, I could always just put a little bit of Loctite on it just to hold it in position. But I think the original kit just come with an arm with a plastic bung, the same as that hole, that just sort of popped in. So yeah, we've just made it in brass. So digital readout on the quill. So the last treat for you on the video is to change the wheel on my RJH FERRET diamond lap machine. This came along with the Fobco drill as a part of a deal when I was buying the machines, but I haven't used it much. It's sort of sat on the bench. It's been bolted down in multiple places, moved about, because unfortunately the diamond wheel on it has yeah, most of its diamonds have left the building, and it no longer sharpens tungsten carbide drills and that kind of thing. So I searched the internet for a wheel this size. It is a funny size, and I did struggle to find anywhere. I found one on eBay and sort of followed it through, and it's a company called ARC. I think yeah, abbreviation for abrasive something or other. UK company. They do a lot of grinding wheels and stuff, and they had one. The lady had one. I phoned up and asked about it, but she said no, that was just the one they had in stock was a grinding wheel just for high-speed steel. So it's an abrasive rather than a diamond lap wheel. And I said, do you do one? She said, yeah, we do one, and I'll get back to you. And she sort of never did. So I suspect the one left was probably new old stock just sitting there. But anyway, I sort of kept looking, and sort of a few weeks later on eBay, a wheel of the right dimensions and a diamond lap came up. And wouldn't you know it, here it is. It's made by ARC. So obviously somebody's bought this a fairly long time ago, and it's been stuck on the shelf and never used. But it was cheaper than the straight abrasive wheel. So there you go. I've got a diamond lap to go on here. Slightly different to that one. But Yeah, you can see the diamond impregnation in it there. And yeah, I learnt about the part numbers, the D on the D6A2. The D stands for diamond, so we can get it back in business again. So we'll get this old one off. And strangely, it's actually metric Allen bolts on it. There we go. So drop that down. Drop the wheel off. Yeah, this was made by SA Limited. Not sure if they're still going anymore. And that's got a D76 on the number there. D for diamond. And then we'll very carefully get this one in. Like a glove. Ah. Need some holes drilling in it. Oh, that's an adapter for there like that. Oh well, job for another day. Right, calamity averted. It's in there perfectly like that. Feed it in without smashing the new grinding surface off. There we go. Nip it up. Try and avoid damaging the new grinding surface. Drop it back a little bit, just for now. Then we'll see. Right, let's fire it up. Noise machine on. Feels pretty good to me. Back in action. Be able to sharpen all these up now. There we go, all back in action. Might relieve it a little bit more, just to clock it on the outside edge here, just to get it running as true as we can, just to cut down any vibration. But apart from that, happy with that. So there you go, a little bit different, but as you see, as I needed to move the machinery around, I needed the space, needed to move stuff around. And that takes a lot of organisation. So I had to put the motorcycles and the cars down, leave them alone for a little while. You know, we'll be back, don't you worry. But yeah, I thought you might like to see how I go about shifting the machinery around the workshop. And there, you can do it on your own. You know, go back to old principles like the Romans, the Egyptians, rollers, you know, scaffold tubes, stuff like that. They're brilliant for moving machinery around. But yeah, just take it slow and steady. Decent pry bars, wooden wedges are your friend. And yeah, you can. It's amazing what you can move like that. But just be very careful because what was it, sort of yeah, 1,750 pounds of cast iron and steel just waiting to kill you if you get it wrong. And the same with this as well. This is even toppy heavier than that. Is that a word? Probably not. But yeah, I've moved this up, put plates underneath, and you know, got it off of a pallet truck when I sort of put it here originally. Yeah, so yeah, just be sensible, just be careful, take it easy, take your time, and it's amazing what you can shift. Yeah, so if you're thinking about big machines, oh, you know, you never be able to get them around the workshop. Yeah, I never thought that, and I've got these two monsters. Well, you know, not compared to cutting edge engineering. Have you seen his latest lathe? Bloody hell, was it 6-foot turntable on it or something? Amazing. Anyway, there you go. I hope you like that. I hope you like the little bit of, you know, explanation of the digital readout on the quill and getting the diamond lap back into operation. So that'll be nice to be able to use that rather than it being a very expensive ornament on the bench. Yeah, so there you go. That'll keep you busy till next time, and then we'll get back to tinkering. All right, okay, cheerio. Right, Jenkins, put the kettle on, make another cup of tea, and we'll have the nice biscuits when they've gone. What are we doing? Poof my hair. Oh, up my bum. Ow. Yep, everybody's happy, and do 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 do.